This video talks about completing the square for a parabola. So we are going to take our parabola off the origin, no longer having its vertex at the origin, but it's going to have its vertex at a point hk, just like we took the ellipse and the hyperbola off the origin. So our general equations are going to be x minus h squared equals 4p times y minus k, or y minus k squared is equal to 4p times x minus h. X minus h, not y minus h. X minus h, where hk is the vertex of the parabola. So we're going to take this equation that I have here, 2x squared minus 4x plus y minus 4 equals 0, and put it into one of those forms. And it would obviously be the first one, since the x squared is the squared term. And you notice that it's a parabola because we only have the one x squared. Now, notice what we're trying to get. We're trying to get a squared term on the left-hand side and a non-squared term on the right. So we're going to put a squared variable on the left and everything else on the right of the equation. So we're going to start out with 2x squared minus 4x equals negative y plus 4. Then we have to go through the completing the squared process on the left side only. So factor out the 2. We have x squared minus 2x plus blank equals negative y plus 4 plus blank. So this is 2 times our binomial now. We have an x and an x in the first term in the binomial. Then to get the negative 2x as a middle term, we'd have to subtract 1 from each of those x's. And then negative 1 times negative 1 gives me a positive 1 for my third term inside the parentheses above. Then I need to multiply that 1 times the 2 outside of that parentheses, and 2 times 1 gives me a 2 on the right-hand side, adding 2. So my right-hand side becomes negative y plus 6. So my left-hand side looks like 2 times the quantity x minus 1 squared. On the right-hand side, notice I want a 4p times in parentheses y minus k, or y plus k. So this has to be just a positive 1y, so I'm going to have to factor out a negative 1, which would leave y plus, or y minus 6 in the parentheses. And then I have to deal with the fact that I have a coefficient on the left-hand side. I shouldn't have a coefficient on the left-hand side, so I have to divide both sides by 2. And that leaves me then finally with x minus 1 squared is equal to negative 1/2 times y minus 6. So this is the final form of my answer in standard form for graphing. And from this I can determine a couple of things. I know that my vertex is 1, 6. I know that 4p is negative 1/2, so p is equal to negative 1/8 if I multiply both sides by 1/4, which means my latus rectum length is equal to 1/2. So this is not going to be terribly helpful for graphing. I'll just tell you that. And one more piece of information, since it's an x squared and the coefficient in front of the unsquared variable is negative, that means we're going to be going downward with the parabolas for graphing. So let me start with plotting the vertex. So since the vertex is kind of farther up, I'm going to put my, actually I think I'll scoot that over just a wee bit. Put my x-axis a little bit down towards the bottom here. So my point 1, 6 is the vertex. 4, 5, 6, there's the vertex. My focus, I'll put this in red, and it's going to be, my focus is 1/8 of a unit away from the vertex. So basically it's sitting right underneath it. And if I were to do the latus rectum, it's going to be a total length of 1/2, so basically 1/4 either direction. That's really not useful for graphing. So when I have a situation like this where the p-value is very small, it's best just to plot a couple other points. So what I usually do is solve the equation for the unsquared variable and then just plot points, make a t-chart. The unsquared variable, not just the unsquared. So if I solve this for the unsquared variable, I would get multiply both sides by negative 2, and I would have negative 2 x minus 1 squared equals y minus 6, or negative 2 times x minus 1 squared plus 6 equals y. This will allow me to put in some values for x and find some values for y. So the best thing to do is put in values that are close to the vertex. So I have the vertex at 1, 6, so I'm going to put in 2 and 3. And because of symmetry, then I can also find the corresponding points on the other side of the vertex. So if I put 2 into this equation, I would have negative 2 times 1 squared, so negative 2 plus 6 is 4. If I put 3 in here, I would have 3 minus 1 is 2, so 2 squared is 4, times 2, negative 2 is negative 8 plus 6 is negative 2. So I have the point 2, 4, and 3, negative 2. Then I can do the same thing on the opposite side of the vertex because there is symmetry, and then draw my parabola. And the directrix is actually just on the other side of the vertex, 1/8 of a unit away. So there's the directrix, very, very close. And that's the end of this video.